Dear sir, madam, and everyone, I am Ngọc Nguyễn from Vietnam. Today, I am very honored and happy to present my research, a proposal of user asymmetric cryptography algorithm. The research was accepted and published in the Second International Conference on Software, Multimedia, and Communications Engineering (SMCE) 2017 in April 21st, 24, 2017 in Shanghai, China. Introduction. Although traditional asymmetric algorithm almost its implementation are successful in keeping important documents confidential, it uses only one private key. This research proposed the use of asymmetric LA algorithm to satisfy the requirement of generating many access keys. Each access key is granted to only one user. This demand is real because a group of members needs to retrieve the same document, but each member requires confidentiality in access. It is known because many generated private keys can be reviewed, but I try my best to create a scheme of LA algorithm as skilled as possible. Some cases in use asymmetric LA algorithm are column vector. If each vector Z is associated with linear mapping VZ, called value of Z, Z, Z1, Z2, Z1, Z, Z1, Z2, Zn, and VZ is the sum of Z1, Z2, Zn. Notation S, S quad, and S double quad denote original document firstly encrypted document and secondly encrypted document. Respectively, in LA algorithm, Z is private key if it is known by only one person, which is totally secret. Z is semi-public key if the number of persons who know it is more than one but limited. Z is a public key if the number of persons who know it is unlimited. And which is, it means that which is totally public. That is the encryption key, which is used to encrypt S into S quad. Here, encryption key E. S quad concurrence with SVE modulo N modulo nui. Let D be decryption key to decrypt S quad encrypted by E according to concurrence with modulo nui. ACMA RSA scheme. D. S quad PD. Congruence with modulo nui with S. That M is a mass matrix which is Mn singular matrix whose rank is M smaller than N. That S be a set key in LA algorithm which is delivered to user. Here, mass matrix M and S. S is a solution of following equation Ms equal D. Let S upper bound S be a set of solution S which is called a set K set. Let cardinality of X which is the number of trusted user. S has following form. Here. S, S1, S2, Sm, Sn. from S1 to Sm is the value of the function f1, f2, fm with variable sm-1, sm-2, sn. F is the set of f1, f2, fm is called retrieval function set, and chi is the set of sm-1, sm-2, sn is called independent set. Thirdly, we generate two larger primes p1 and p2 and relate to positive case E and D according to RSA scheme. ED concludes one with modulo phi, where phi is the bonification of b1 minus 1, b2 minus 1, and nu is the product of two primes p1, p2, and so SED concludes S with modulo nu. Case D and E are related such that VE equal lowercase e and VD equal lowercase d, and we generate randomly n minus 1 integers a12, a13, a1n to create the matrix M. Here, Ke, Kd, and mass matrix M. We generate randomly s minus 1 integer lambda 2, lambda 3, lambda n. A set K S is created so that S is a solution of the equation Ms equal D. S Ms equal D. S1 here. Two equation is very important. This is the scheme of LA algorithm. The scheme uses three private cases M, E, Q, and one semi-public case encoded a set case S squared equal S divided by Q. Pool S, user U, and center C are responsible for keeping E, Q, and M totally series respectively. The simple scheme of LA algorithm is shown in the figure here. Step 1, step 2, step 3, step 4, step 5. So the scheme of LA algorithm has the 5 steps. Step 1. Secure pool S encrypt S into S squared by private key E. User U requests for S by providing public key S squared to center C via the communication channel L1. Consequently, C receives S squared equal S divided by Q, and M squared equal D squared, and S double squared congruent to S squared V D squared modulo nu. C retrieves S squared from pool S via the communication channel L2. This is the step 3. Step 4. C creates the key D squared equal M S squared and encrypts S squared into S double squared by D squared. S double squared congruent to S squared V D squared congruence to SVE VD quark, congruence to Z, congruence to SVE VD, power the inverse of Q modulo nu. Step 5, the last step. C send S double quark to U via the channel L1. Consequently, U decrease S double quark into S by gravity Q. S double quark Q, congruence GQ, congruence SVE VD, congruence S with modulo nu. The schema of LA algorithm with noisy technique. The scheme of LA algorithm with noisy technique. We generate gravity Q equal RT and create S quark with noisy key N. Here, N Q00. N quark is the N divided by T equal to R00. S quark equal S subtract N. Here, S1 subtract Q, S2 Sn. User U send two semi-bubonic keys N quark and S quark to center C as step 2. C creates both noisy data W quark and S double quark form S quark by M N quark and M S quark as step 4 and as step 4. W quark congruence S quark V, M N quark congruence S quark R with modulo nu. S double quark congruence S quark V, M S quark congruent S quark V D subtract Q with modulo nu. C send both W quark and S double quark to U, and then you decrease S double quark into S by T and W quark as step 5. Here, W congruence to S quark Q with modulo nu. S double quark W congruence to SVE VD, congruent to S with modulo nu. This is the scheme of our algorithm with group acceptance. Let yi be the compound access key of user UI. With that, yi is a sequence of on encoded access key accept S I quark yi here. This equation is the specify the source sequence. Yi equal S quark 1 source S quark 2 source S quark me here. Instead to suppose user US request for S by providing YS to center C. If center C receive on YI, that's on user provide as their acceptance. C will make a full source sequence of YS and on YI to recover the encoded access key SS. Here, this equation specify the recover source sequence. Center C will create the K the quark from the multiplication the quark equal M S S quark in step 4 A usual A usual. This equation is the source sequence, the encrypt source sequence, encoded source sequence. But the equation is the recover recover source sequence. And finally, set C will create the key the quark from the multiplication M S S quark. The conclusion: the ideology of the use of symmetric array algorithm is simple, which only applies some concept in theory of linear algebra, but the scheme of implementation is complex. For each user, the schema uses four keys, where a traditional asymmetric algorithm uses only two keys, which causes the efficiency is decreased two times. However, LA algorithms satisfy the requirement of many users who want to access same document in confidential manner, and it is possible to keep track asset log for restricting asset attack. Moreover, our algorithm is more practical and flexible than traditional asymmetric algorithm, which react to the aforementioned requirement. For each user, the schema uses four keys, where a traditional asymmetric algorithm uses only two keys, which called the efficiency is decreased two times. In the future, I will build up a camera system for online monitoring via mobile phone with a group of authenticated users. Because video stream is dynamic data, we need to create one window W1 as Boon S, one window W2 as Center C, and one window W3 for each user U. Following is the possible flow of streaming data. Firstly, streaming data is encrypted firstly by private key after flowing through W1 and it goes to W2. It is encrypted secondly by key D squawk equal MS squawk after flowing through W2 and then goes to W3. Finally, it is decrypted by private key after flowing through W3. User U now can view it. Data reference. Thank you for your attention. I am very honored and happy to answer your question. Thank you again.